Welcome to Davika Academy. This is Davika, and we are looking at special calculus functions, and this is very interesting because these are the ones that you cut across through the numerical analysis or across in an application, a complex analysis. You'll expect to come across these kind of functions. So if you have not subscribed to this channel yet, kindly subscribe and join to this community because we are growing and we need to grow together as we share this kind of knowledge. If you have any question about anything about calculus, be ready to leave it here as a comment. Add more knowledge because community is there to build one another. So this is Davika Academy. Today we look at special calculus functions. Okay. So the first special calculus function is exponential. So I want to see how we can work out with the integral of ex. So generally you expect to get that one ex plus a given constant from a given constant. For example, if you have I want to get the integral, so you have to integrate 2e for x and the x, okay, and I want to integrate this. Remember 2 is a constant, so you put it outside there and you integrate. So if you integrate 4, so you start from here. This way you start from here. I want us to go together. So you start from this, you differentiate, you do like you are differentiating, and when you integrate that part, you are getting a quarter, so you'll have 1/4, okay, and so you have that. Then we take this part is a constant now, so it will remain the way it is from now the above special function. So it will become e for x and of course plus a constant c. So this concept, to elaborate more on this part here, what is going on here, I want us to recall something. The integration by substitution. We looked at it previously in the previous discussions, and if you have not looked at it so far, kindly look at the link above. So look at this. So we let in this scenario t be 4x, okay, be 4x. Now in this case, differentiate this in respect to x. So this one will give us 4, okay. Now we want to differentiate to substitute dx, or else to write dx in terms of t. Therefore our dx, you see our dx is equivalent to dt over 4. You get dx. So that now in our equation here we can substitute. We can substitute our integral. So our integral here is integral to e. Remember, e is 2 power 4x, but in our case our 4x have now become t. So you see, if we do this, our dx now is dt over 4. So now you see our integral now is in respect to t. So that if you check at this part here, this part here, and these two here, you'll find is approximately what we have here, and hence that kind of substitution. So breaking down this, you'll find that this is now giving us half and get half we are getting e half e power 4 x plus a constant. So clearly you can see this. So because my interest here was on how to come up with this, it is clear that we should not be having this now here, because already we have undergone the integration, and that is it about how we work out with this kind of special functions. That's how we work out with the special functions. Okay, next let's see another form. So now we have this form here. It's a form of ax, integral of ax, a power x dx. So if you look at this integral here, if you want to see how this is playing, we let ax now to become a y. Okay, and if we do applying the idea we have just reduced there for substitution, you do dy dx, and clearly you'll see that we are having dy dx of these, we are having ax, okay, ln ln a, it follows to this in a. So you can see we are having this, and this tells us what? It tells us that y, which is now this, is same as the integral of this, which will imply that if we need to get now the integral our ax now, it is same as having ln of ax of a integral of ax and dx. So what does this tell us? It tells us that now this form here, this part, which is this part of course, this part here, is same as actually the a power x, okay, ln natural logarithm of itself. So that's what it tells us. So now That is now the reason we are calling these kind of integrals as special ones. So you can see the way they are playing. The way they are playing. Very interesting. Very interesting. So if we like to look at an example here, and we see how it is going to play. So suppose now we have we are told integrate to this kind of equation here, 2x dx. Okay, so by default, from what we have just said, since we get the ax, so we expect to have x, which is 2x in this case, over the ln of a. You see, then 2, and of course a constant is expected. We expect a constant. So you can see how it is playing. You can see how it is playing. Okay. So this is very interesting, and so on and so on. So this is the play. In case you have any question on these topics we are passing across, kindly leave a comment and let your friends know we have this community that are joining that is pure for mathematics, and we are here to help one another, remember. Okay, now let's look at another form. Here we have a form which is the form integral of x inverse, and if you do x inverse, you automatically get the ln of x, the ln of x plus a constant. So this is just like that. We can play this with this kind of equation here. So we do integral of 3x over x squared minus 1 dx. So you want to get the integral of 3x. Let us write x clearly. So we do, this is 3. Okay, so looking at this, can we apply our normal knowledge? We use substitution. So here we can let our t, so that we see the play now, we let it to be x squared minus 1. So that from here our dt will be equal to 2x dx. See the way it is playing now. So it will be 2x dx. But remember, you need to compare these kind of equations very well. You compare. See, our interest here we have x, 3x dx. So we need to have a relationship between this part here. See, x dx. So from this relationship here, if we need x dx, so what do? We actually get half of this dt. So that now we say our dt will be same as x dx. So when you're working on this, you look at a relationship. You look at a relationship. So that if you have this kind of scenario here, clearly this becomes integral of 3. You can put 3 is a constant, so can come out. So x dx now is dt. You can also put 2 outside, so divided by 2. Okay, then over the x squared minus 1 is now our t. So now this form here, this equation here, yes, so this one, if you look at this now keenly, you'll find that now it now gives you the form that you are looking at, this one. So you can see this now can be now will give us now, because we have in t here, so it becomes ln of t. But our t is now x squared, but because we have not substituted it, we put plus t. So that now we now introduce our proper values. So it becomes 3 over 2 ln x squared minus 1 plus a constant. So that's how you play with this kind of special form of the integration. Okay, now we have the other 2 forms which they follow the suit. So we have this one. Remember, if we integrate this, we use we let this one be t. Something is happening if we let this one to be t. We have t being equal to x plus b. So you can see here our dt is same as the other one is a constant, and dx. So that our dx is actually d on dx is actually dt divided by a. So if we substitute that one and dt, this one is dt, we are having 1 over t dt, and the 1 over a is outside here. So that's it's the way it goes. But this is now becomes from the previous form that we have just introduced. So this clearly you can see it in giving you 1 of a ln t. So that's actually the other side here. If you look at the other side here, you can see what is happening. What's happening? Our t now is now a minus bx. Okay, so that our dt here is now negative bx. So that now if you look at this one, our dt, or else our dx, okay, this is now, let's see what's happening. Yeah, this is negative b. So that's now our dt now. Our dx is negative now. Here, change to negative dx. So that's now the key difference with these two forms. Then it will mean this now we'll have now 1. We will have now negative 1 over b as our solution now, ln t. Of course, that is a constant. So these two forms here, I'm basically playing with they are basically these two forms here. They are basically playing with the previous kind of form, that special form that we have looked at. So that's all what I want. If you have not subscribed to this, kindly subscribe. Kindly share also with for any questions on this question. Leave there as a question that we can look at through our comments, and comments that we can support the Vika Academy community with. So it's about this. Until next time, we say bye.